Now question 5, pretty much exactly like question number 4, except for there's just one extra step whenever we're trying to simplify. But the first couple of steps are exactly the same. We can go ahead and combine this under one big radical, and the reason it works out nicely for me when I do that is because 192 can be divided by 8 evenly. 192 divided by 8 ends up being 24. Now I know that's not a perfect cube, but that doesn't matter. What we're really trying to do is get rid of this fraction, and because it divides evenly, that works. So that's why we want to combine it under big radical. If it didn't divide evenly, this is the way to keep going. It starts splitting, finding conjugate, all of that. So since it divided evenly into 24, even though it's not a perfect cube, that's okay. We still need to simplify this. We're not done because we can actually keep simplifying this radical by splitting it. We're going to try to find 3 of a kind, right? That's what we're trying to find right now. So splitting it up, we got 6 times 4. If you wanted to do 12 times 2, that works. We'll actually do that later just to prove that you can do these factor trees a million different ways. As long as those numbers actually multiply to get the number above it, it's good. So we just found 3 of a kind. We got 3 2s. 2 is going to go on the outside. We're going to copy the cube root. We started with a cube root. We end with a cube root. That will never change. The only thing that changes is the number inside and then number outside. So the number inside is going to be what we couldn't find a match for, and that was 3. So this is going to be our final answer. I want to prove to you that a factor tree is still going to work, even if you decided when you saw that 24, well, the first numbers that came into your mind might have been 12 times 2, and that works. And I'll show you how it works. The only thing is I can't split that 2 up, so I'm going to have to focus on the 12. 12, see, 6 times 2 equals 12. If you did 3 times 4, guess what? That also works. So we got 3 times 2 times 2 times 2. It's the same pattern. Look, it also worked. It gets us the same answer, 2 cube root of 3. Now let's say that I did it again, just to show you how much it can change. If we did that 12 times 2, but instead we said, hey, 3 times 4 equals 12. Let's say you didn't say 6 times 2, you did 3 times 4. Well, guess what? Still works. Still got 3 2s and a 3. So don't get stuck on a factor tree just because it doesn't look nice and evenly like mine. If you choose different numbers, like one is really big and the other one's kind of small, it's going to work. You're just going to have more of a lopsided tree. You still get the same answer though.